Hey, what's going on, everybody? Today we're going to be going over something that's been kind of highly requested, and it's been in my plan to make this video for a while now. We're going to be taking a look at policy-based routing. And of course, we're going to specifically be configuring this on an edge router, but policy-based routing is not specific to the edge router. It's just one of those advanced configurations that it just happens to support, which is great for everybody. So let's go ahead and take a look at it. So what is policy-based routing? Well, say you've got your router and you've got a couple devices down here connected to it. And we're also going to say that you have two internet connections. So this is where policy-based routing is most commonly used when you have more than one internet connection, because what you want to do is say you want this guy over here, host 2, to communicate with anything on the internet using ISP2. And say you want host 1 on the left here to communicate with the internet only using ISP1. So this is where policy-based routing would come in handy, because by default your router is only going to have one active default route at a time. So any host on the network is going to be using one or the other, unless you have something like load balancing configured, but we're not going to get into that. But the reason that your router is only going to use one of these is because it has what's called a routing table, and it has a main routing table for everything on it. And the routing tables will make sense a little bit later when we actually get to configuring this. But let's go ahead and look at another example that we can use policy-based routing for, and that is, say we have two routers, either in our network, not in our network, or whatever. We got some hosts off of one, hosts off of the other, and a connection between them. Now each of these might have their own WAN connection or internet connection. Let's say there's a host over here that we want to communicate over this other router instead of the one it's directly connected to. This is another situation where you would need to do something like policy-based routing, because by default this computer over here is probably getting its address with a gateway for this router, which has a default gateway of this ISP. And to get it to go over here is a bit tricky. So how are we going to configure this? Well, pretty much all of it's going to be in the command line. These configurations don't really exist in the graphical interface. Technically they do if you go into the configuration tree, but I hate using that. Using the command line is just easier than trying to figure that tree out. But here's going to be our test environment. I have this set up in like scenario number 2, the one I just showed you. I have a computer here connected to this router, and its LAN is 192.168.80.0, and our edge router is .1, that is the gateway for this client, and it is connected to the WAN. We're going to pretend that this is just a regular internet WAN connection, but its address is actually 10.88.13.109, and its gateway is 10.88.13.13. So obviously these are private IPs, but we're going to pretend that they are a WAN, and we've got this router connected to another one over here, also with a WAN connection, and it doesn't actually have a host connected to it, but we can just move a cable and bring our test computer over to this one. But its LAN is 172.16.80.0, with its gateway also is .1, and the computer getting whatever address it'll get through DHCP. Now this other router does have a WAN on the exact same network as the other one, which won't make a difference, but its gateway is the exact same, this 10.88.13.13. That's the WAN gateway for both of these routers. Now this little link in between here is actually routed, and the reason I'm making it routed instead of just a switched interface is because we can kind of think of this as a VPN connection, maybe, between two edge routers in two different locations. I'll get into what that can be used for later. But for now, this link is 172.16.0.0, and we have .1 over here and .2. So the way this is set up right now, I have routing and all of that set up on each of these, because we would need a static route on edge router 2, or the one on the right, to our 192.168.80.0 network, and we would also need a static route on edge router 1 pointing to our 172.16.80 network. Those have already been configured. That's not really a part of the policy-based routing. That's just a part of getting this set up to function. but if you do try to replicate this, just know you will have to put in static routes for these two LANs to actually communicate with each other. Now at the moment, our host down here is getting an IP address on the 80 network, and it's using .1 as its gateway, and anything that it needs to get on the internet is going to go off to the internet using the Edgerouter 1's interface. But what we want to do is say we don't want this computer using that for its internet connection. We want to send it to Edgerouter 2 and have it use Edgerouter 2's WAN connection. So that's what we're going to be setting up in this video. Now, what do we need to get all of this working? Well, if you want to follow the official guide, there is this one here. It's called Edgerouter Policy-Based Routing. This is on Unify's actual help website. And this takes you through step by step on how to set up policy-based routing. Now, there's a few commands in here that aren't really going to be applicable to our scenario. This one is written with the two different VLANs and two different ISPs in mind, which is the most common reason to use this. Just because we're doing a different scenario doesn't really mean it's going to be that different. The concept is still exactly the same, and the commands are mostly identical. But if you want to follow along with that, this is here for reference. But let's go ahead and just kind of visualize what it is we're going to be doing on this. And one of the first things is going to be basically creating a second routing table. So by default, you've got your routing table named main, and that is what holds all the routes for your router, your default gateway, your local LAN interfaces, and any other static or dynamically configured routes that your router may have. Now, for us to do policy-based routing, we need basically a second routing table that does not have all these routes in it, because we want our device to use a different route than what's in the main routing table. So we're going to create a second routing table, and we're just going to call that PBR for policy-based routing. And the second thing we're going to need to do is make a firewall rule, basically just to classify the traffic that we want to apply this policy-based routing to. So this is really just going to classify our source address. So this would be the address of our host that we're wanting to modify the routes for. And then lastly, we're basically just going to tie this firewall to an interface. So like switch 0, which is the default LAN interface for an edge router, and then test it to make sure it's working properly. So if this is as clear as mud, awesome. Let's go ahead and jump right into the configuration. So right now I am connected to the web interface of both edge routers. We've got Edgerouter 1 and Edgerouter 2. Right now our host is connected to Edgerouter 1 here on port Ethernet 1. And I have a remote connection to that host right here. And if we go just download a test file, I'll go ahead and save that. If we go back to our Edgerouter interface, we can see the WAN of our Edgerouter 1 is getting a lot of traffic, 265 megabits, as well as ETH1. So right now our host on Ethernet 1 of Edgerouter 1 is using what we'll call ISP1, or the internet connection of Edgerouter 1. And what we want to do is configure this to where when we go over here to Edgerouter 2, we actually see it utilizing this WAN interface instead, because for some reason we just don't want it to use this WAN interface. We want it to go over to this router. So to do that, we're going to open PuTTY and SSH into our Edgerouter 1. So 10.88.13.109 is the WAN address of that edge router. And I have the WAN access set up for SSH. This would by default be blocked by the default firewall on an edge router. So in your use case, you would probably be using the LAN interface to SSH to it. But let's go ahead and log in. I have the default UBNT, and enter configure mode. All right, and now the first step in our list, so I'm going to be just going down the list of this policy-based routing guide from Ubiquiti, and I'll be mentioning kind of what applies and what doesn't apply. So the first thing that this guide wants us to do is to make sure we have 2 default routes added to the main routing table. And it says this step is necessary to allow hosts to use the main routing table in case one of the ISPs is down. This is true, but a lot of the times, unless you have a business class internet connection, you usually have a dynamic public IP address. And that just means that your edge router is probably getting its WAN address with DHCP. And if it's doing that, it's automatically getting both of these static routes dynamically. So this is a step that I usually don't do, but if you have a static IP and a static default route, you can go ahead and throw in the second one in there. But like I said, if they are dynamic, really if one ISP goes down, you're going to lose that DHCP configuration, and it should just fail over to the second one anyway, especially if you have something like load balancing set up for it. Now, this step number 3 is going to be the one that we're mainly concerned with, and that is this set protocol static table 11 route next hop. And what these two commands are is it's creating a second routing table called table 11 with a default route of this 203 network, so that's ISP 1. And then we're creating another routing table called table 12 with a default route of the other ISP. And this guide is doing the two different VLANs using two different ISPs. So VLAN 10 will use ISP 1, VLAN 20 will use ISP 2. This is a little different than what we're doing, but that is how you set up the two different routing tables for this. Now on ours, we're going to go in here and we're going to create our other routing table, which is set protocols static. We'll name it table PBR, and then we're going to put in our default route. So set protocols static table PBR route 0.0.0.0/0 next hop, and our next hop is going to be the IP address of router number 2. So let's go back to our whiteboard and look at what we got. So the next hop for this routing statement is actually going to be 172.16.0.2, which is this interface. And really we could use this 172.16.0.2, or we could use 172.16.80.1. We could actually use that since this router has a route for that interface, but best practice is to use the actual like physical or virtual next hop, which would technically be this .2 address because that's the one directly connected to us. So back to our command line here, next hop 172.16.0.2, and hit enter. And I guess we can't use names for our table names. It's probably why they used numbers in the actual guide we're following. So we're just going to call this table 10. Why not? So table 10 route, our default route of 172.16.0.2. Now let's go ahead and commit this change, and then we can verify it if we exit out of configuration mode and do a show IP route. We can see this is the main routing table of the router. But if we do show IP route table 10, this is the routing table that we just created. So our main routing table has its own default route of 10.88.13.13, but our second routing table, table 10, has a default route which is different. So now that we've got our tables set up, let's go ahead and make the firewall rules, which actually classifies what device is going to use this other table. So we're going to go back into configure mode. We're going to do set firewall modify. We're going to call it PBR. And we'll just start with rule 20 like the guide says. Rule 20, this is just which order it's going to be using these. And it's good to put in a description first. We'll just call it description policy route. And then we're going to do the same thing, set firewall modify PBR rule 20, and we're going to give it the actual source address. Now this is going to be the source address of the host or network that we want to apply policy-based routing to. So for our example, we only want this one host to use the other ISP connection. So let's get the IP of that. So now I'm on that host, just do an IP config, and we can see apparently it's using a wireless connection. Also, I'm just going to disable that so that our testing doesn't get messed up. All right, Wi-Fi is disabled. It should be using the wired connection anyway, but I don't want to figure out that our testing is all jacked up down the line because we have a wireless adapter on our test host. So up here at the top, Ethernet adapter has an IP of 192.168.80.40. So that is going to be the address we use in our configuration here. So 192.168.80.40. And because this is just a host address, we're going to use /32. So that's a host mask. If we were doing the entire 80 network, we would do 80.0 in /24. But 80.40/32 gives us our host address for our firewall rule here. And then we're going to tell it what to actually do. So set firewall modify PBR rule 20. And the action this rule is going to take is to be modify table 10. And we'll go ahead and hit enter, and I'll just explain these real quick. This first line is literally just the description that shows up if we look at this rule either in the GUI or in the command line. This is the one that actually classifies traffic from our 192.168.80.40 host. And then this last command is telling it what to do with that traffic, and that is to modify it to use routing table 10. Now at this point for our setup, all we have to do is apply this to an interface. So set interfaces, and we'll do switch 0, firewall in, modify, and the name of our firewall rule, which is PBR. Go ahead and hit enter. And switch 0 is not a valid name because this command, I believe, is set interfaces switch 0. There we go. So left out the second switch name in this command. So set interfaces switch 0, firewall in, modify PBR. And this is just saying that we want this firewall rule set that we just created to apply in the in direction of switch 0. And then now let's go ahead and commit these changes and exit out of configuration mode. Well, let's go ahead and just save it first. It's good to save your configurations after you're done. Exit configuration mode, and we should be able to actually verify that this is working now. So that's all we had to do to set up policy-based routing in this way. And if you're wondering about the other sections in the article that I didn't cover, I'll go over those here in just a second. But let's go back to our test PC, and we'll go ahead and do another IP config just to verify. Yes, it has the same IP. Yes, it has the same gateway. But let's download this test file again. Go ahead and save that and go back to our user interfaces. So let's refresh the GUI of Edgerouter 1 because we made some changes. And we can see now our internet connection is not being heavily utilized, but our host connection here is downloading at 200 something meg. Actually, it looks like it might have just stopped. Oh, nope, there it is again. And our interface connected to our second edge router is the one that's actually facilitating that traffic. And if we go over to our Edgerouter 2's interface, you can see it is using its WAN interface. All right, so why is this useful? Well, let's go back to our drawing board here. Like I said, the most common reason to do policy-based routing is when you have two internet connections on the same edge router and you want either an entire network or VLAN basically to use a secondary internet connection instead of a primary. And there's multiple reasons for wanting to do that, like a voice network, a failover network, or maybe there's just certain devices, if you have load balancing set up, that don't handle load balancing very well and you want to lock them down to a single ISP. But why is this scenario that I just showed you useful, where we have two different routers, two different internet connections? Well, at the drawing board, let's try to imagine this as like two different houses. And this is maybe a VPN connection instead of just a straight cable. And let's say that these are the actual like WAN addresses instead. There's certain applications or things that you can use. I'm not going to name any real names, but some of them kind of like to cut down the use of password sharing between different households. And one of the ways that they like to classify this traffic is by public IP address. So if you've got a whole lot of hosts using a certain service and they're coming from a certain IP address, and then you've got another host that tries to connect to that same service and it sees it has completely different public IP, there's probably a good chance that that's not really you using that service, and that's probably something that is using a shared password or something. But say you've got a VPN between those two places that you are definitely using this service yourself at, and you don't want to put in the additional work that might be required to use this service. If you have policy-based routing, that traffic can instead be routed over a VPN to another location to use that WAN interface. And I cannot confirm nor deny that that is what I use it for. But that is the use case really for this setup. But the concepts, again, are still the same. Now let's go back and look at the parts that I skipped from the main guide here. So I've already said that we skipped the setting 2 static routes because usually you're using DHCP. Go ahead and do this if you're not using DHCP on your WAN connections, but typically this configuration isn't really needed. We did accomplish step 3. The only thing we didn't do is create a second table, table 12, because in this example they're using policy-based routing for 2 different VLANs, where in our example we only set it up for 1 host. And this is literally the exact same thing as the command we did. It's just you would use a different next hop interface for the second ISP. And this note that it says is if you're using PPPoE or OpenVPN, you can use an interface route. All that is just stating which interface it is going to send that traffic out instead of the next hop IP. And I know there's a lot of people out there that use PPPoE, but typically Ethernet is going to be the protocol on your WAN interface, and it's best practice to use next hop IP if it's an Ethernet. Now, step 4, which they labeled optional, is exclude the inter VLAN traffic between VLAN 10 and VLAN 20 from PBR. So what this section does is it creates a network group, which classifies the 2 different VLAN networks. So in this example, they're saying that the network 10.0.10.0, which is VLAN 10 for them, and 10.0.20.0 are both going to be a part of this group called VLANs. And then they set another firewall modify rule, and their description is inter VLAN, and their rule classifies the network group VLANs, which just means that both of these networks are going to be modified by this firewall rule. And then their action rule is to modify table main. And the reason they do this is because if you want to talk between VLAN 10 and VLAN 20, this might be a little bit better to draw. So here we've got our 2 hosts, VLAN 10 and VLAN 20, connected to the edge router with 2 ISPs. Now the rules that they outline in here are basically saying anything from VLAN 10 use ISP 1, anything from VLAN 20 use ISP 2. But what if you want to talk to a machine that's on the other VLAN or communicate just directly between these? When you have these policy-based routing rules, because it's not using the main routing table, these other VLANs do not exist to each other. Because what the traffic will do, if you try to access VLAN 20, this computer will send it to the edge router, it'll look at the policy-based routing rule and say, oh, well, your default gateway or next hop is this ISP. So then your traffic is going to get to this ISP who's going to be like, who's VLAN 20? And just drop that traffic because it doesn't have a route to your internal network for sure. So what you have to do is create that rule which says both VLAN 10 and VLAN 20, if they are the destination, which is the keyword in their thing, or which is the keyword in the configuration here. When we set up ours, it was source group, but this is destination. So it means anything destined for either VLAN 10 or VLAN 20, use the main routing table. And that is how you maintain your local routing between the 2 different VLANs while using policy-based routing for the WAN portion of it. And because we weren't modifying routes for 2 different networks, we were only doing it for a single host, we didn't need to do anything like that. Now, step 5 we did, that is creating the rule to identify our traffic source. So we did that, and then we apply it. We also did that as well, commit save. Now, these other commands at the bottom are just kind of how to verify everything. So show IP route table 11, we did that. We saw, well, for our table 10, we saw that it had a different static route or default route for that table, and show IP route was how we looked at the main routing table for the router itself. But we didn't do this show firewall modify PBR statistics, so let's go ahead and bring up our edge router here and show firewall modify PBR statistics. This just says which rules are being matched for our policy-based routing configuration. And we've got rule 20, that's what we said to identify traffic from our host. And you can see we've got a ton of packets and a ton of bytes for the modify action policy route. So our rule is working, and we already verified it was working, but this is just another way that you can. If you see 0 and 0, that means nothing's being matched by that rule, so policy-based routing isn't taking over. Now, one more thing, just in case you need another example of something, let's go ahead and just change our IP from .40 to something else. So we're going to go ahead and give ourselves a static IP configuration here, and instead of using 80.40, we're going to use 80.41. Click OK, click OK. wait for the remote session to come back up because we had an IP change, close out of that, and if we try to download that file again, because we did not classify either the whole VLAN or the IP.41 in our rule, this is now going to be back to using our Edgerouter 1's WAN address. And you can see our host PC is using the ISP of this router now instead of the second one. And if we wanted to change that, all we have to do is go into configure and modify our firewall rule. So let's just do a run show configuration commands grep PBR, which will show us anything in our configurations that contains the letters PBR. And this was that rule that we made, action modify, description policy route, modify table 10, source address. So what we can do is just delete firewall, modify PBR rule 20 source address, and set firewall, modify PBR rule 20 source address. And we'll just do the whole VLAN, 192.168.80.0/24. And if we commit, then this changes the rule from only classifying a single host to use the rule to the entire network. So now basically anything connected to our only LAN on our Edgerouter 1 isn't going to use the internet connection that is directly connected to it. So let's refresh since we changed the configuration. Go and download our test file again. And we can see it downloading, but not using the WAN connection of this Edgerouter. And if we go over to Edgerouter 2, boom, it's using that now again because we expanded that rule. And that's pretty much all we need to cover for policy-based routing, really. Like I've said, I don't know how many times in this video, typically you use this when you have two internet connections and you only want a certain network or device to use one over the other instead of what your router is doing by default. And this is one of those questions that I've gotten quite a bit in the comments. The question's never really, can you go over policy-based routing? It's, all right, what you just showed me was really cool, but how can I make it like only use one interface or whatever? Like the question gets asked a lot where the answer is policy-based routing. So I figured I would go over that in this video. You can do this on many different devices. The Edgerouter is not the only one that can do something like this, but it is an advanced configuration that not every device supports. So your mileage may vary in that department. But anyways, as always, hopefully you learned something. If you have any questions, leave them in the comments below. And also, as always, happy networking.